The advice to stand up every 30 minutes was never really about standing. It was about a small calf muscle called the soleus, buried deep underneath your calf, that researchers found can keep burning extra blood sugar even while you're sitting. Most people were only told to walk it off, so they never heard about the muscle doing the real work. And if you've got a desk job, back-to-back calls, a laptop you can't leave, a chair you're glued to for 6 hours at a stretch, that advice doesn't feel like health advice. It feels like a chore you're failing at. Every notification telling you to stand up starts to feel like one more thing on the list you didn't do today. So most people either ignore it, or they do a quick lap around the office once an hour and hope that's close enough. Here's the part almost nobody explains. The real goal was never simply standing up. It was getting one very specific muscle to keep working. In 2022, researchers at the University of Houston discovered something about this muscle that completely surprised them. When they activated this tiny, buried calf muscle using a specific, slow movement, it nearly doubled how much fat and blood sugar it burned compared to ordinary sitting. Even crazier? It kept burning fuel for as long as the movement continued, for hours, not minutes. Most muscles act like a light switch. You exercise, they burn fuel, and when you stop, the burn fades. The soleus behaves more like a pilot light. It isn't dramatic, but it stays on, quietly clearing glucose from your bloodstream while you stay completely seated. But how can a muscle work for hours without getting tired? This comes down to its unique evolutionary design. Most of your large muscles, like your quads or biceps, rely heavily on something called glycogen, which is stored carbohydrate fuel packed right inside the muscle tissue. When you run or lift weights, those muscles rapidly drain their glycogen stores until they hit a wall and burn out. The soleus is the exact opposite. It is packed almost entirely with slow-twitch, highly oxidative muscle fibers. It has a lower than normal reliance on glycogen. Instead, it prefers to pull its fuel directly out of your passing bloodstream, vacuuming up circulating blood glucose and fats in real time. It is virtually fatigue-resistant because it bypasses the internal fuel tank and sips directly from the endless highway of your blood. That's mechanism number one. But to understand why this is a complete game changer for desk workers, you have to understand the second problem your body is fighting every day. Every time you eat, sugar enters your bloodstream. To pull that sugar out and use it for energy, your muscles use a tiny cellular gate called GLUT4. Normally, your body needs insulin to act as the key to unlock the gate. But if you spend years sitting down, or if you have insulin resistance, that key doesn't work as well. The gate stays locked, and sugar stays in your blood longer, slowly damaging your blood vessels and increasing your risk for type 2 diabetes over time. But groundbreaking research out of Denmark revealed a brilliant backup system. Simply contracting a muscle can open that exact same gate without needing insulin at all. Squeezing and relaxing the muscle acts as a second, independent key. When you sit all day, your largest muscles go completely dark, meaning that second gate stays locked. But because the soleus can run continuously for hours without running out of breath, it gives you a way to keep unlocking the gate, flooding your cells with sugar clearance even when insulin is struggling to do the job. To see what this looks like in the real world, meet Priya. Priya is 44 and works as an accountant. Every 30 minutes, her phone reminded her to stand up, but client calls and spreadsheets always got in the way. After another yearly checkup showed her fasting blood sugar had crept higher anyway, she felt completely defeated. So, she stopped chasing step counts and tried something much smaller. Right at her desk, she started doing quiet, seated heel raises for a few minutes after lunch. At first, she thought it felt too small to matter, like flossing one tooth. But it quickly became an automatic habit she did while concentrating. A few months later, her after-meal blood sugar readings had improved so much that her doctor asked what she had changed. She smiled and said, "Nothing big. I just stopped worrying about standing up and started doing this instead." Now you might be wondering, if I can just do this while sitting, why can't I just shake my leg or tap my foot? This brings us to the fascinating biomechanics of what the researchers call the Soleus push-up. Your calf isn't just one muscle, it's a team. The big, visible muscle on the back of your leg that gives your calf its shape is called the gastrocnemius. The gastrocnemius is a powerhouse built for explosive movements like jumping and sprinting. Crucially, it is a biarticular muscle, meaning it crosses over two joints, your ankle and your knee. When you are standing up with a straight leg, the gastrocnemius is fully stretched and takes on almost all the work when you lift your heels. But when you sit down on a chair, bending your knee at a 90-degree angle, something remarkable happens. The gastrocnemius becomes mechanically shortened and slackened. In biomechanics, this is called active insufficiency. Because your knee is bent, the massive gastrocnemius is effectively turned off and taken out of the game. The soleus, however, is a monoarticular muscle. It only attaches below the knee, crossing solely over the ankle. Therefore, when your knee is bent at 90 degrees and you lift your heel, the soleus cannot hand off the work to its big brother. It is forced to isolate and carry 100% of the load. Sitting down isn't a compromise. It is the only way to isolate this specific metabolic powerhouse. But the science gets even deeper. The benefits of isolating the soleus go far beyond just managing your blood sugar spikes. When the University of Houston researchers tracked the systemic effects of the Soleus push-up, they discovered that it completely rewired fat metabolism in the body. Normally, when you sit still for hours, your body's fat-burning enzymes, specifically one called lipoprotein lipase, shut down. This causes fats to linger in your bloodstream longer, raising your cholesterol and increasing fat storage in the liver. But keeping the soleus activated during the fasting periods between meals actually doubled the normal rate of fat metabolism. It led to a dramatic reduction in VLDL triglycerides, the specific, dangerous circulating fats associated with fatty liver disease and cardiovascular plaque. By activating just 1% of your total body weight, you aren't just protecting your pancreas. You are actively clearing the liver and cleaning out the fats floating through your cardiovascular system. Her results match exactly what scientists are now proving. In 2025, researchers tested this seated movement on people with prediabetes during a standard sugar tolerance test. The result? Doing these quiet heel raises reduced their post-meal blood sugar spike by a massive 32% compared to just sitting still. Now, this doesn't mean walking has lost its value. A famous study from New Zealand found that a quick 2-minute walk after eating drops blood sugar spikes by about 27%. If you can get up and walk, do it. But many of us simply can't leave our desks every half hour. Lowering blood sugar isn't a house with only one door. Walking is the front door. The seated soleus movement is the side entrance. The goal is just to give your body more options. Quick question for you. After lunch, how many hours do you usually stay glued to your chair before you finally stand up? Drop your number in the comments below. So, here is the honest, step-by-step protocol. Because if you do this wrong, you'll end up using the wrong muscles or causing ankle strain. First, check your setup. Your knees must be bent at roughly a 90-degree angle, with your feet flat on the floor. The movement itself is the exact opposite of walking. When walking, your body tries to minimize energy expenditure. For the soleus push-up, we want to maximize it. You are going to push down through the ball of your foot, lifting your heel as high as it will go. At the absolute top of the movement, pause for a split second to feel the deep contraction underneath your calf. Then, let the heel smoothly lower back down until it kisses the floor. Do not bounce your heels like a nervous habit. Keep the cadence controlled, roughly 2 seconds on the way up and 2 seconds on the way down. Start doing this about 15 to 20 minutes after you finish a meal, right when your blood sugar starts to climb. Aim for just 3 to 5 minutes at first. As it becomes a habit, you can easily do a few short sessions spread across the 2 hours after you eat. This isn't a miracle cure, it's not a replacement for medication, and it's not a reason to skip the gym. It is simply a highly effective, scientifically proven tool for the parts of your day when getting up is impossible. You were never failing because you couldn't hit 10,000 steps between Zoom meetings. You just weren't told that one of your most helpful muscles was waiting to work for you. Sometimes, better health starts with a smaller movement, not a bigger one. Every week, we break down the real science behind everyday health trends, so you can stop wasting time on things that don't work. Subscribe and tap the bell so you don't miss the next deep dive. See you in the next video.